Today we're going to recap Learning Target 5, which is what we've been talking about over the last few days, which says I can write a linear function or inequality that best models a real-world situation. Remember that words that imply equals are is and are. So if you see is or are in a situation, that usually means equals. If you see words such as at least, more than, greater than, bigger than, or at a minimum, that usually implies that it's going to be greater than. So you're either going to use that symbol or that symbol with a line under it. And words that imply less than, to use these two symbols, would be no more than, less than, smaller than, or maximum. So if you see any of these words in a situation, you are going to use the corresponding symbol over here. So that's how you choose the right sign for this situation. Equals, less than or equal to, greater than or equal to. Now, real-world situations usually come with a set of data in a table. Either the table can be given to you or you can make your own table. Here's how to write a function given that set of data. So the first thing you're going to ask yourself is, do you have the y-intercept? Remember, the y-intercept happens when the x-coordinate is 0. And if you do have the y-intercept, if the answer to that question is yes, you're going to use slope-intercept form, which is like y equals mx plus b. So you can use slope-intercept form. You could also pick a different point and use point-slope form, but sometimes slope-intercept form is easier. So if you do have the y-intercept, like right here, when x is 0, you can use slope-intercept form. So you're going to take your y-intercept, you're going to find the slope, and this function is going up on the y's, and it's going up by 1 on the x's. So the slope is going to be 5 over 1, because it's always rise over run. So your function, you're going to take your slope, which is 5 over 1, and your y-intercept, which is 13. You're going to put the slope right there for m, and you're going to put the y-intercept right there for b. And that's how you're going to write your function. So the function is going to be y equals, or you could say f of x equals 5 over 1 is your slope, x, so m is 5 over 1, x, plus b is 13, so plus 13. That's your function. If you don't have the y-intercept, you can't use slope-intercept form because that requires the y-intercept. So if you don't have it, you have to use point-slope form. Use point-slope form. And for point-slope form, you need the slope again. It says you need the slope. So to get from negative 3 to 6, that means you're going up 9, up 9, up 9. And over here it's going up 1. So your slope is 9 over 1, or just 9. I always pick the top point, so I'm just going to pick that point. You can pick any point. And so your function is going to follow this. The slope goes there still. This is the y-coordinate, y-coordinate of the point that you picked. And this is the x-coordinate of the point that you picked. So the y-coordinate is a negative 3, so that's going to be a negative 3 right there. The x-coordinate of the point we picked is a 5, so that's going to be a 5. So our function is y minus, I'll do it over here actually, y minus the y-coordinate, which is negative 3, equals our slope, which is 9, and then x minus the x-coordinate, which is 5, so x minus 5. Now the only thing you could change here is, if I zoom in a little, this minus a negative 3 could actually be plus, because if you subtract a negative, you're actually adding. So you could actually say y plus 3 equals 9, x minus 5. In point slope form, it always ends up looking like the opposite of what you see over here in the actual point. This looks like a -3. It actually looks like a +3 over here. This looks like, or this is actually a +5. It looks like a -5 over here. And the reason is because these minus signs right here are part of the equation, and they're going to change it into the opposite in the equation. And the last thing, when you use your function to answer a question, so let's say we have these functions now, and we're using them to answer a question, we're going to always ask ourselves, does our answer make sense? If you get a negative result, if you plug something into this function, our negative's okay in this situation. To get a decimal, our decimal's okay. Does it make sense? So that's how you can model data with linear functions. And yeah, we'll start talking about Learning Target 6 next week.